That stream in your backlot is a power plant, not metaphorically, but measurably. A spiral geometry, first used 2,300 years ago as a water pump, has been reversed by modern engineers into a turbine that converts flowing water into electricity at up to 80% efficiency. No dam required. It can be built for under $1,200 in materials. By the end of this video, you will discover why American Energy Code ignored it and how to build one yourself. Hi, I am Oliver and welcome to Off-Grid Ohms. Subscribe and hit the bell for more videos uncovering electrical secrets. Power in watts equals head in meters, multiplied by flow rate in liters per second, multiplied by gravity, multiplied by efficiency. A stream dropping 1 meter at 20 liters per second produces roughly 160 watts, running continuously. That does not sound like much until you realize it runs 24 hours a day, 8,760 hours a year without interruption. That trickle generates 1,400 kilowatt hours annually. A rooftop solar array produces equivalent energy only 4 to 5 peak hours per day. A stream does not stop for clouds or darkness. It is baseload power. In 2006, the Idaho National Laboratory published a study for the Department of Energy assessing water energy resources across the United States. The study identified over 130,000 sites suitable for microhydro generation under 100 kilowatts. Fewer than 2% have ever been developed. A modest stream with 2 meters of drop and 30 liters per second flow generates over 12,000 kilowatt hours annually, more than enough for a household running day and night. In 250 BC, Archimedes of Syracuse designed a helical blade wrapped around an inclined cylinder to lift water from low ground to high ground. Archaeology pushes even earlier. Stone reliefs from the reign of Sennacherib, dating to around 705 BC, depict spiral water lifting devices. Strabo documented identical mechanisms along the Nile. The genius is the geometry. A helix inside a cylinder set at an angle. In its original form, you turn the screw and water rises. Reverse the operation and water turns the screw for you. That reversal is the modern key insight. Water enters at the top. Gravity pulls it through each pocket. Every pocket pushes the blade. The blade turns the shaft. The shaft spins a generator. The Roman engineer Vitruvius specified optimal pitch angles of 37 degrees in 15 BC. Researchers, including Chris Rohres at Drexel University, have tested these ancient specifications against modern computer simulations. The Roman geometry approaches calculated optimal efficiency. 23 centuries of knowledge in one shape. From the 1500s onward, hundreds of windmill-powered Archimedes screws drained the low-lying farmland reclaimed from the sea across the Netherlands. Modern Dutch waterboards still operate Archimedes screw pumping stations today. Same geometry, updated materials. By 1850, Britain operated over 25,000 water-powered mills, proving that low-head water power could sustain entire communities. Then in the 1990s, German engineer Karl August Rodlik asked the reverse question. Instead of using power to lift water, what if falling water turned the screw to generate power? Where a Pelton wheel needs 50 meters of drop, the reversed Archimedes screw generates electricity from just 1 meter. Most garden streams qualify. Today, at Hosham Mill in Yorkshire, a modern screw turbine generates 30,000 kilowatt hours annually for the local village. Same site that ran a water wheel in the 1750s. In rural America, before 1936, thousands of microhydro installations powered farms and small communities across Appalachia, the Pacific Northwest, and the Mountain States. Then, in 1 decade, the practice vanished. It did not vanish because it failed. Something more profitable arrived. In 1936, Franklin Roosevelt signed the Rural Electrification Act. The objective was noble: bring grid power to every farm. The consequence was devastating for energy independence. Every working microhydro system became redundant overnight. Farmers abandoned free power for the convenience of a monthly bill they would never stop paying. A farm generating its own power buys nothing from the grid. The centralized utility model needed customers, not competitors. The Federal Water Power Act had established licensing requirements for hydroelectric installations back in 1920. As grid power expanded, these requirements made small-scale generation increasingly impractical. Industry publications celebrated the retirement of independent generation as progress. Engineering curricula dropped small-scale hydraulic power by the 1960s. The knowledge was not disproven, it was defunded. But across the Atlantic, they kept building. The United Kingdom operates over 400 Archimedes screw installations. Germany and Austria have hundreds more. Documented efficiency sits between 78% and 82%. The United Kingdom Environment Agency classifies them as fish-friendly, with survival rates above 90% for most species. So what stops an American homeowner from building one? The Federal Energy Regulatory Commission requires licensing for any hydroelectric project on waters of the United States, including streams crossing private property. The process takes 2 to 5 years and costs $50,000 to $200,000 in fees, for a system costing under $1,200 in materials. The 2013 Hydropower Regulatory Efficiency Act streamlined conduit projects, but new natural stream installations still face the full burden. Many states classify any in-stream structure as requiring dam safety review regardless of size. Every kilowatt you generate is one you do not purchase. The codes are written against you, but water flows downhill and a spiral turns. First, you need to know what your stream offers. Measuring head is simple. Place a stake at your proposed inlet point and another at your outlet. Run a string level between them. The vertical difference is your head. Measuring flow takes a bucket and a stopwatch. Narrow the stream into a single pour point. Time how many seconds to fill a container of known volume. Divide volume by time. That is your flow rate in liters per second. Multiply head times flow times 9.81 times 0.8. That number is your continuous wattage. Take multiple measurements across different seasons. Spring runoff may triple your winter baseline. Design your screw for the lowest reliable flow, not the peak. A system sized for minimum flow produces power year-round. A system sized for maximum flow sits partially dry for months and wears unevenly. You want consistency over peak performance. The essential components are a helical blade formed from split, thick plastic pipe or from sheet steel, a central shaft of galvanized steel pipe, a trough of poured concrete, or a halved corrugated culvert, shaft support bearings at each end, and a low RPM permanent magnet generator. To form the helix, cut your pipe lengthwise into equal curved sections. Weld or bolt each section to the central shaft at your chosen pitch angle, offsetting each flight evenly around the circumference. 3 flights is standard for low head applications. The trough must match the blade diameter closely. Allow 5 to 8 millimeters of clearance between the blade edge and the trough wall. Anything more and water slips past without pushing. For the generator, select a permanent magnet alternator rated for your expected shaft speed. Most Archimedes screws at residential scale turn between 15 and 60 revolutions per minute. That is far too slow for standard generators, which expect hundreds or thousands of revolutions per minute. You have 2 options. Use a gearbox or belt drive to multiply shaft speed up to the generator rating, or use a purpose-built low revolutions per minute alternator designed for wind or hydro applications. The second option eliminates mechanical complexity and the efficiency losses that come with gearing. Low revolutions per minute, permanent magnet generators that produce useful voltage at 30 to 50 revolutions per minute are available from wind turbine suppliers and typically cost $200 to $400. Ground your entire system properly. Water and electricity demand respect. Use weatherproof enclosures for all electrical components. Mount them above the highest flood line you can identify on your stream banks. Run buried armored cable from the generator housing to your battery location. Keep the run as short as practical. Every meter of wire costs you voltage. Total investment lands under $1,200 for a system producing over $1,000 in annual electricity value. The ideal pitch angle is between 22 and 35 degrees. Research your specific state and local requirements thoroughly before beginning any project. The spiral does not need firmware updates. It does not break down after 15 years, so you will not be buying the next model. It turns 24 hours a day silently. The same geometry that lifted water for Archimedes is now reversed into something that belongs in every backyard with a stream. The energy industry calls it a regulatory challenge. The stream does not care what they call it just keeps flowing. If this changed how you think about electricity, subscribe to Off-Grid Oh Mess with Oliver. Please watch the next video appearing on your screen right now.